Hey guys, it's Simon and welcome back to the LibGDX Kotlin RPG tutorial series. This is one of the last parts that we are going to have in this tutorial series, and in this part we are going to introduce some music and sound stuff to our game, that we have a background music for our map and also some sound effects, for example when our player is attacking, or when a slime is dying, or when we open up the chest. And I want to have this part in between the next one. The next one will be about the AI behavior trees, and the reason is that in the last part with the state machine handling of our player, that was already a quite long part, and maybe when you heard that for the first time, also a very complex part. So that's why I want to bring it now in my opinion, easier part, a little bit more relaxing before we go over to the final part. What I noticed when I was rendering again the videos and I was looking over the code is that first of all I forgot to mention the difference that I wanted to say about the AI entity, where I mentioned in our spawn system, I mentioned that in the video that we need to be careful to add the state component after we have added the live component here. And the reason for that is that I have a different code on GitHub, so in my project. So there, as you can see, the state entity, which is actually our AI entity basically, there in the constructor I check if an entity has a live component, and if yes, then I set this check a live state, and if it does not have a live component, then I do not set this check a live state, because it's not necessary, because if the entity cannot die, or if it does not have any hit points, then it can never be dead, or it can also not be resurrected. But since we are not using that, we only use the states for our player, so we can simply skip that portion here of the code, and we did not introduce that. And yeah, that's why we don't need to be careful when we add the state component in our code. I just wanted to mention that because I forgot that. And the second part, which I actually did not like, is how we handled the resurrection state. So let's go to our default state. And what we did, so for all of the different states, we always had the transition code. So when we changed to a specific state, we had that also in as part of the other states. So for example, here we changed to the state attack, here we changed to the state idle, and we had that for everything except for the resurrection state. There, for whatever reason, I put that directly into the dead system, which in my opinion breaks a little bit the approach that we used for that, and that is what I want to quickly fix now with you, because I think or I know we can solve that differently, and I fixed that already in the GitHub code. So let's do that now also in our tutorial before we start into the music and audio part. So let's quickly go to the dead system, and there where we have that code here, so where we set this resurrection state, let's simply remove that. So we get rid of that in our that system. We can also remove the state components because we don't need them anymore, and then we can go back to our default state, and there simply now in the dead state we can implement here also now an update method. And that one is fairly simple because we simply check that if the entity is not dead, we already have that available, then we just change the state to the resurrection state. And that would be it, because if an entity is dead, so for example our player is falling down, he has no life points anymore, and he has this dead component added to it, so then when he gets resurrected in one of our systems, I think it's the dead system actually, at one point he is not dead anymore, and when that is happening we simply want that he gets resurrected, so we simply change to that state. And now, in my opinion, it's handled in a cleaner way, because now all the state transitions are really visible in this default state or in the state handling that we have here, and we don't break here our approach. So this is a small adjustment that I noticed when I watched the video, which I did not like. So I prefer that way. And as mentioned in the GitHub code, it is already fixed. Okay, so the big part now of this part is the audio system that we are going to introduce, or the audio management, so that we can play some music files, we can play some sound effect files. And the approach that I used in this game is a different one that I normally used in some other games. So normally what I had in some other games is, let me just quickly open a random file. So normally what I had is I call it normally an audio manager, and that one simply included some different methods. So for example, you could play a specific sound, which we learned then in this part, which is from LibGDX sound. Then you can also play a certain music and things like that. And then simply whenever I wanted to play a specific file or a specific sound or music effect, then I just need access to this audio manager, which could be, for example, an object, a singleton, but normally I created that in my game, and then just pass whatever system or whatever logic needs something from an audio management part. It simply gets then the audio manager that got created, and they are simply called in the play method. So for example, we have a random system, whatever that would be. We don't care, maybe an attack system or something, and there we have an attack function. And if a player or an entity would now attack, then this system simply takes in, for example, the audio manager, which would be the audio manager from above, and then in there we can simply call them play and, for example, attack sound, whatever. So a specific sound file. So this is how I managed it in all my other games, but in that game I wanted to try out something different, and what I did here, or what we are going to develop also now together, is that we actually react on certain events. So we will not have an audio manager, we will have an audio system, and there with the scene2D event handling that we already learned and used already throughout our game, we will simply publish some other events. So for example, an entity attack event, an entity death event, whatever. So we just publish different events there, and our audio system will react to that and then simply play sounds that, yeah, it will then, so it will contain some logic. So for example, when an entity attack event is published, then we also know what kind of entity is attacking. So is it the player, is it the slime? And then the audio system is simply looking up the sound file that needs to be played and will play it. The advantage that I see with that approach is that you don't have your audio management coupled into anything else, because for example, the attack system, it won't know that there is actually an audio manager, and also in my opinion it does not need to care. It simply does something like stage, fire, and then attack event, and for example an attack event for the player or whatever, and then it does not need to know who is reacting on this event. In our case, for example, the audio system, it does not need to know that, and it's then very, I would say, flexible and also modular, because it's not bound to a specific implementation of an audio manager. So it does not even need to know that. So that's the advantage that I see there. The disadvantage is that, yeah, it's maybe not that straightforward when someone looks into the code. So when such an event gets fired, you won't know that there is actually also an audio playing with that event, and maybe other things like, I don't know, in your user interface you're showing something when such an event is happening, or other things like that. So you don't directly see that. So that's why I leave it up to you what kind of thing you want to implement there and which solution you prefer, but just that you know it. So for this part, or for this tutorial series, I'm implementing an audio system which simply reacts on certain events and is then playing a file instead of implementing an audio manager. Okay, let me remove that file and let's start. Okay, so I would say let's start with the music. So for example, the way I implemented it is that when a map is changing, then we check if our map has a specific property. So for example, a background music file or music property, whatever. And if that property is set, then we simply play that specific music in a looped version so that it repeats itself and again and again. And for that, we already have most of the things available. And what we need to do now, so as mentioned, we will create a new system for that, and let's call it audio system. And this system is an event listener because it reacts on these scene2D events, from which we know then what kind of sound file or music file we need to play. So what is the difference between sound and music? I come to that in a moment. And also it is an interval system. Maybe one thing that I did not explain here yet is why are we actually not simply playing the sound or music file directly in the code? So for example, just load the sound file and play it immediately. We don't do that because it could happen that within a single frame, the same sound file is played multiple times. So imagine you get attacked by 2 or 3 slimes at exactly the same time, so the same frame, and then the slime damage sound, for example, is played 3 times for that same frame. And what that means is that simply the volume of that sound file is 3 times louder than it normally would be. So that's why we need some sort of logic which remembers what kind of sound file should be played in that specific frame. And if it is the same sound file, we don't want to play it. We only want to play it once and not multiple times, to avoid that we somehow have a super loud sound effect. So this is what we want to remove. So we want to have some logic there. Also for the music stuff, normally you want to handle it in a more nicer way, because you could, for example, maybe you have imagine an RPG like a Final Fantasy game, and you have a normal background music for your city, for example, where you currently are, and then you have a specific cutscene or a specific event, and you want to, maybe someone dies in your RPG, and you want to switch just briefly to a sad music. So you will play then this sad music, but then after that you simply want to go back to whatever music was before. You don't want to remember that. You could also change, maybe the music file changes through the development for that city background music, and you simply want to go back. So to have that kind of logic, so for example, what was the previous music file, how can I go back to that? Maybe you even want to return to where it stopped before. So all of that logic is, at least for me, normally in such an audio manager, or in this case a system, that you have that available. So it's not normally as simple as just, hey, play that file and that's it. Normally you want to maybe stop the previous music, start the new one, support looping, non-looping, all of that different stuff. And that's why, in my opinion, it's better to have that in a separate class or separate logic at least. Good, so for this map stuff, so that we have some background music, here we already know that we have such an event available. So when the event is a map change event, then we want to first of all return that we handled this event properly. So we return here true. In all other cases we return false for now. And now when a map change event is happening, we want to get the property from our map. And there we want to get a string property, and maybe we create that in a moment. Let's call that, for example, a music property in our map. And if that one is available, then this will be the path to the audio file. So this is the string representation of our music file. And there, first of all, maybe log some message that we know what kind of information we got here. And then we are going to create a music object out of that. So this is what LibGDX uses for a longer played audio file. So LibGDX in general distinguishes between a sound. Let me show you that. So there is a sound available in libGDX, and there is also a music available in libGDX. And the sound is usually used for shorter sound effects, so like an attack sound effect or an explosion or a power up or whatever. So those are usually the sort of short living audio files. Those are the sounds objects in libGDX, and the longer ones, like a background music for a map or for a city or whatever, those are then the music files. And the difference from what I remember, so I think the music is then simply streamed in a special way from the hard disk and will consume more memory usually than a short-living sound file, which is, I think, simply destroyed once it is played, and that's it. But the details you would need to look up in the libGDX documentation. For us, important is music, long audio files, and sound, short sound effects. That's the difference. Okay, so let's quickly introduce a logger down there for our audio system, and then up there we simply want to log what kind of music we got here. So changing music to, and then whatever path we get in here. And that should already theoretically work when we add the audio system to our world. Let's also do that we don't forget that. Does not really matter, I would say, but let's put it at the end of a frame that it gets executed. And because of our general code, so whenever a system is an event listener, it gets already added to scene2D, and we are loading already a map at the beginning, so we should already enter that specific code here. And what kind of music file are we using? There, simply check out the GitHub repository. It's a music file from opengamearts.org, which I always mention usually in the credits. So let me quickly show you that. So what I always do is that down there in the credits here, I usually mention what kind of assets I use and where I got that from, even if people don't want that, or maybe they don't need that the credits are shared, but I always do that. And there you can find, for example, the map music that I used, which is from OpenGameArts, and there it's this OGG file of the little town. And yeah, I simply copy now or take over that music file from the original project, because we're going to play that in a moment. Okay, so what I normally do is in the assets folder, I create an audio subfolder, and in there we have now this fields OGG, which is the music file that we saw before on OpenGameArts. And also I already copied over the different sound effects that we're also going to introduce in that part, which are simply short living wave files for the sound effects. But now for us, we are focusing on this fields file that we want to play when a map gets changed or loaded. And for that, when we open up our editor, where we have our map, so this should be the one from the YouTube tutorial series, yeah, exactly. There we can go to our map and check out the properties of our map. And there we see already, okay, so we created already a property, it seems like, which we called here map music with some background stuff. Now let's change that a little bit. So we called it, first of all, music, not map music. And the path to that audio file would be audio, and now it's fields.ogg. Then let's save that, and now back in our code. So now here we want to load now this music file, set it that it's looping so that it repeats itself again and again, and we also want to play that. And what we want to do, we want to cache that. Usually this is what I always do, so that we don't load the file again and again, or even multiple times. So we just want to have it once, and if we have already loaded it before, then we just load the cached version, which is already in the memory, to be there a little bit faster in the future when changing to different music files. So let's introduce a so-called music cache, which is simply a mutable map of a string, which will be the file path to the music file, and then a music object. And down here, so our music is then from our cache again, and there we either get it or we put it inside if it's not available. So we get here the path, and when it is not part of the map, then we simply return it. And there from GDX audio we can create a new music, so there's a method for that available, and there we go to a file of the assets folder, which is simply the path that we get in there from from our map property. And we also modify this music object, and there we use the apply method from Kotlin and set, for example, the is looping to true, so that this music is then really looping. And down there, so up there, we have now either we loaded this music file or we have it already available in our cache, and then we simply need to play it now. And that's already it for the music part. What we need to do, of course, is now when the system gets disposed, then we need to iterate over all the music objects that we have loaded, and we need to dispose them. So those are disposable resources again. And that would be already everything that we need for a background music, I would say. Okay, so here we can remove the string. That's a small improvement because its path is already a string, so we can keep that. Okay, let's try it out. We should now already hear some background music with that. And we do that. Well, it's quite loud for me. Okay, so let me close that. But yeah, that is already working. So we hear already some music, which is great. So that part is already working. Now, the only thing that is missing are now the sound effects, like an attack or a slash sound effect, for example, for our player. So what we do here, in this part, we will simply introduce new events. So we won't only have a map change event, we will also have something like, for example, an entity attack event. And when we get such an event, we don't have that yet, we will create it in a moment. Then, as mentioned now, we don't want to immediately play that sound file, because again, it could happen that in the same frame, the same sound file gets called or played multiple times, and then the volume would simply pile up and get super loud. So that's why we want to handle that in a sane way and only play it once if it happens multiple times. So there we will call a special method that takes care of that. Let's call it queue sound, because we actually want to add that to a queue, that specific sound. And it would be then so how this event looks like is that it passes also the information of the model, let's say, of the entity which is attacking. So in case of the player, we would get the information that it's the player. In case of the slime, we would get this information that it's the slime. So it is the atlas key of the texture. And why do we need that? Because the way I handled that in a very general way is when you have a look here at the different sound files. So there's always, for example, the prefix. So that would be this atlas key, like player, slime, or chest. Then an underscore, and then what kind of sound effect that would be. So in the attack event, it would be then player underscore attack or slime underscore attack for that. Then there will also be def events. Then it would be again player, so this texture atlas key underscore def or slime underscore def. And there will also be like a loot event. And there, for example, it would be from the chest, this model, or this atlas key underscore open. So the first part is always the atlas key of the texture that I used for that. And the last part is what kinds of sound file should be played. So is it the attack, the open, the def, whatever sound file. So this is how that works, and this is this naming convention that I used in here to have then an easy way of handling those different sound files. So in that case, what would it be? So all our sound files are in the audio folder, and then we get from that specific event, we called it, I think, model, if I remember correctly. Let me quickly check. Yeah, so let's use this animation model. So it would be the event model, and from there the atlas key. And then underscore, and here it would be this attack wave file. So again, coming back to our sound folder, which I unfortunately closed now, but I can show it to you here. So here it's always this underscore attack for the attack event, and it's always a wave file. Okay, so let's quickly create this entity attack event. So let's go to our event file, and there we will have this entity attack event, which has a model, which is an animation model, and is also a scene to the event. Okay, and now, for example, we can enhance our attack system. And here, for example, at the top, so where is it? So here, attack intention and ready to attack. So here we want to publish now this attack event so that whatever logic we're going to implement can react on something when an entity gets attacked, and or when an entity is attacking. And in our case, that would be the audio system to play a specific sound file. So what we need here is, first of all, our stage, which we currently don't have in here. So let's bring it in. And then down there, let's make a call to our stage and fire an event, which we called entity attack event. And there, from the animation components, we get the model. Okay, so coming back to our audio system, we should have now this event. Perfect, and we can also access the model and the atlas key, which is also great. Now we only need to implement this cue sound function, which takes the sound path as a string, and now we need to implement that. And the way I implemented that is that I have like a sound request queue. So as mentioned, I will check, so in this queue, is there already the sound path in it? If no, I will add this request to the queue, and if it is already there, then I simply ignore this additional request. So up there, let's create a so-called, let's call it sound requests, for example, and this is simply a mutable map again of the sound path and the sound object that should be then played. So here, let's also make a debug message that we know that something gets called here. Queuing sound of this sound path. And now we have our sound requests available, so we can write that in a more Kotlinish way. So if the path or sound path is in our sound requests, then already queued, do nothing. So we simply return here because we already have that available. And otherwise, in our sound requests, we take up that sound path and assign it to the sound that should be played. And the sound we are also going to handle in a very, very similar way like we did it here with the music. So there will also be a cache again, so that we know, or that we remember the sound files that we have already loaded and don't need to load them all the time and again and free it up in our memory. So simply copy and paste that one here, the music cache. We will also have a so-called sound cache, which is a map of sound. And then, like we have it here, so the sound that we are going to play is from our sound cache, get or put again, the sound path, and if it is not part of the map, then we use now the other GdX function, which is the new sound. So before we used the new music function, now we use the new sound function. And there it's again GDX files internal, and there it's the sound path that we get in here. Okay, and also the same, of course, here with the sound cache. We also need to dispose any sounds that we have loaded in our game. So let's also add that here. And that should be it for the queue sound. So if the sound was already queued, we don't do anything. And if it's the first time, then we add it to the sound requests and say here what kind of sound should be played. So that's very, very simple and a basic implementation of how that could look like. So the only thing missing now is that we want to play actually those sound requests. And since we are using an audio system, which is one of these advantages, so whenever our world gets updated, our entity world, we also enter now the onTick method, which is called every frame, the way we set up our audio system here. So now we simply need to iterate over those sound requests, play the sound file, and also clear then the sound requests at the end when everything was played. So here we simply check now, so if our sound requests is empty, so if there is no request, then we don't need to do anything. That's the easy path. And otherwise we iterate over the different values of our sounds, and we then play it with a specific volume. You can also enter here a pitch and a pan value, but in our case, let's say we always want to play it with 100%. So the volume is a value between 0 and 1, as you can see here. And yeah, 1 means with 100% volume. You could also add here, you can imagine that maybe in an option menu, you allow the player to make a setting for the sound volume and music volume, and then pass in here the value from that options menu. But for us, we have it very simple. It's just to demonstrate how that works and how you could implement something like that. So for us, we simply pass in here 100%. And after all those requests get played, we then of course clear our sound requests, because now we have played all of them. So we are done with it. That should already be it. So now when we attack, then with our player, we should already hear an attack sound effect. Let's see. And we hear that. So when we attack now, so now we get this player attack sound effect as well. What we are missing here is that, for example, we have a death sound also for our slime when they are dying, or that when we open the chest, that there is a loot sound effect played. Boy, I really have to scream because the music for me is super loud. Yeah, so this seems to work, which is really great. So let's add also those two other events. So an entity death event for the death sounds, and for example, an entity loot event for the loot sounds, which is very similar like we have it here with those events. So let's have another one which we call, for example, entity death event, and then another one which is an entity loot event. Of course, you might need to pass in here other information, like loot event could be that first of all you have the entity which is looting, and then the second argument could be the entity that gets looted, for example. So you can of course mix that up with whatever you need it to be. For us, we keep it again very simple. It's just a demonstration. So for the death event, we also just get in the model of the entity which is dying, and there we play the death sound. And for example, for the loot entity, we play the open sound. So let's come here to our attack event. Here we also simply created 2 more times. So we have a death event, and we also have a loot event. And now let's also add that to our system. So the death event would be in our death system most likely. So there, when an entity gets removed here, then we most likely want to publish here that it really died. So again, we need access here to our stage. And we also need access to our animation components. And now here, so before we remove the entity, because we need access to all of its components and so on, so we're going to fire a new event, which is an entity death event. And there again, we pass in from the animation components of that specific entity, we pass in the model. Just one final time that I repeat it. So the way we are now creating here those events and also passing in this information might not be perfect, because you can imagine maybe not every entity has actually an animation. Maybe you don't even want to read that out of the animation, what kind of sound file should be played. So this is really just a demonstration that you see how you can play the sound and music files and how such a system could look like. But I don't recommend to simply copy and paste that and use that for whatever game you want to have. Please adapt it to whatever kind of needs you have in your game, and yeah, use it then in that specific way. Don't just blindly copy and paste my code here. Again, just a demonstration. Okay, so this would be the def event, and the last one would be the loot system, for example, where we know here, so down there was now an interaction, and there we can now also fire a loot event. So here again we need a stage. So here we remove the loot component from that specific entity, and yeah, let's maybe here at the top we can also now fire an event, which is an entity loot event. And same as before, from the animation components from that entity we pass in the model, and now we should also get first of all the def sound from the slime and also the open sound from the chest. Let's try that out. Oh, and we also have to import first here the events in our audio system. Now we should be good to go. Okay, I made I made the music a little bit silenter, or how do you say that? So not that it does not have so much volume. So now let's kill the slime. I heard a sound. Yeah, so not sure if you could hear that in the video, but I could hear it, so this is already working. And let's also try out the chest. Yeah, so this one is also playing its sound effect now. So great, so this is everything that we need. So now we have background music playing, we have sound effects playing in our game, and we are super happy with what we have, I would say. Great stuff. Yeah, and with that, that's actually it for that part. So the only thing that is now really missing, and that is now coming in the next part, so that's the last part then most likely of this tutorial series, is now the AI of the slimes, because everything else we have now available. So we have now finally a player movement, we have the state handling of our player, he can die, he can get resurrected, we have the collision handling, the dynamic creation of this box 2D objects, we have all the rendering available, we have an attack system with some floating text that we see what kind of number or damage we deal. Yeah, so the only thing is really that is missing now are those slimes, which are currently still very stupid. So they just are standing there and they are waiting for the player to kill them. And now in the last part we are going to give them also more logic that they actually do something and act a little bit more smarter. Okay, thanks for watching. That's it for the audio part. Have fun and see you in the next one. Bye bye. Hey guys, there's one small thing that I forgot in the last part, which I did not mention. So this part is recorded after I actually finished the audio part where we developed the audio system. And I remembered that actually I had some problems with some sound files. So that LibGDX was throwing an exception that it could not read the WAV file because it had a specific sample size which was not supported, something like that. And if you also have this problem, then the easy solution for me that I found out is that you just download Audacity, which is also a free program that you can download from the internet. I will also link it in the video description below. And there, for example, simply open then the WAV file that you have. So those are our existing ones, which are already fixed, but it does not matter to show it to you. So for example, when we have this attack sound file, then you see the different waves and how it looks. And then simply you go to exports and then store it in the format that was the original format, I would say. So if it was a WAV file, then also just save it as a WAV file. And there you can see below the encoding, and there choose the signed 16-bit version. Because I think if it's 24 or 32 or something like that, there was a problem, at least for me in LibGDX, loading that. So then just use it as that, export it as that, type in the new name, and that's it. That solves that little exception. So this is a little piece that I forgot to mention, but now that's really it. And now I'm going to record the last part of this tutorial series. See you in the next one. Bye bye.